So, good evening, everyone who has. Am I audible to you and is my screen visible to you? Please just confirm for once. I hope it is my. I am audible to you and my screen is also visual. So, I will wait for few minutes to join. We will be starting at just one quick question. Both of you, Vishnu and Sai Chanda, have you joined my last session? Miss, you were present in my last session. You can just write in chat. You no need miss. If you want, you can write in chat box. Yes, no. Just I'm asking. No, miss. It's not. Okay, no problem. Present in previous. Okay, no problem. So we will wait. I will start at 7:05. Okay, I just wait for 2 more minutes. So good evening, everyone. Welcome to the second week of online discussion. So as you might been, welcome to the second week of this online discussion on wastewater treatment and recycling. This course is being taken by Manoj Kumar Tiwari sir. In your NPTEL portal, it might be showing that he is from IIT Kharagpur, but recently in October 2023, he has joined IIT Kanpur. And my name is Manitam Prakash, and I am a PhD student in environmental engineering in Department of Civil Engineering. And I am one of the. There are total three TA, and I am one of the TA for this online discussion. So I am present every Tuesday from 7 p.m. to 9 p.m. via Google Meet, and the link has been already shared to you. And the recording of this session is being uploaded on YouTube channel, so you can, if you have any kind of doubt that has been discussed during this session, you can always go back and check it on. So that so so in second week, in first week we saw the basic of the wastewater, like what is wastewater, what was its source, what are different components in wastewater, why treatment of wastewater is necessary. So after that we move on to second week, where we focused on these three things, these five things, that is wastewater generation and qua- quantity estimation, means how much wastewater is generated we have to predict. So my final, if you go through that, this top means course topic, it's water treatment and recycling. So if you want to treat something and if you want to recycle something, you must know how much water you have to treat. Depending upon that, you will be constructing your treatment plant, or you might be controlling on the flow, how much water should be what water should be coming into your treatment plant. It all depend upon the quantity of the wastewater, so we have to estimate it. So because it's no, random, it's very random thing, because one house might produce too much waste, one house might produce less waste. So you have to make a rough estimation. So rough estimation, so there are some scientific way through which we try to estimate the wastewater generation. So we will be looking, these have been discussed to you, some formula has been given, some some numerical examples has been also shared with you, like how you can estimate. So before estimating directly the numbers, before going into numbers, you know should know the basic, some basic definition. So those basic definition was shared with you. And I am assuming that you have all gone through the week second lectures. So there, miss, if you have gone through this uh, second week lecture, you might be aware of the terms which will be used in questions and all this thing. Then quality estimation of sewage, then population forecasting method. So this is most important thing, population forecasting method. So why this is important? So now imagine that you are build you are working in KMC, and you municipality corporation, and you are assigned to build a treatment plant. So obviously you will be building a treatment plant. You cannot build treatment plant for current population, because suppose current population is, suppose for one particular area the population is 1 lakh. So you can miss, and 1 lakh population will be generating some kind of wastewater. So you cannot assume that you have to treat that much amount of wastewater, because in future that population will be increasing or decreasing. But the trend is such that the population is always increasing. So you have to you have to build the your treatment plant in a such a way that it can fulfill, or it can treat the water that is being generated currently. And may suppose you are treating, you are planning to construct that treatment water for 50 years. So your treatment plan should be able to treat a water after 50 years also. So miss you have to design your different treatment unit, like you in future you will, in upcoming lectures you will be seeing what are the different treatment units. And each different units have a particular amount of particular amount, this much amount of water it can treat, or this much water can it can uphold for treatment. So you have to design in a such a way that it does not exceed its design capacity. So obviously after may 10 years the population has increased to 1.2 lakh. So more wastewater has been generated. Obviously the more population, more wastewater. So your treatment plan should also treat those wastewater. So that's why the population forecasting method is very important. So I think in today's session, this the population forecasting method is most important thing you should know, because when we are designing there is something called growth factor. Like we have to be concerned about that factor, like how much population, how much will be a growth factor. Depending upon that I have to design my treatment unit. Okay, so we will look into some numericals how this forecasting is done. There are several methods. Then quality estimation of sewage flow. Like sewage flow means, I hope you are understanding the sewage flow. Like uh, uh, in your house the wastage is being produced and it has to be transported to treatment unit. So how the flow will happen and all these things. So you have to estimate that also. So that will help you to design your uh, sewage pipeline and all these things, like how much big, how much diameter should be there for passing the wastewater that is being generated from your house to final treatment unit. So that you have to estimate, because depending upon that estimation only you can design several things. You can design like how much flow should be there, how much should be the capacity of your treatment plant. So overall, depending upon how much quantity of wastewater is generated, what is the population, final aim is to build a proper treatment plant that will including sewage like sewage pipeline also. Like if wastewater is being generated in your house, that will be carried via sewage pipeline to treatment plant, and finally the treatment plant will treat that water, and finally depending upon the degree of treatment that can be either discharged or that can be reused. So what is the reuse and recycle, yeah, discharge we have discussed in last lecture. Like we have focused, like if you have done some advanced treatment, like you have treated it in a very advanced way, then there are high chances that you can reuse that water. But if your treatment level is not up to mark, that had converted this water for reuse purpose. So generally, what is it recommended by several environmental control board, that you may discharge your treated wastewater in either land or in river, depending upon the degree of treatment. Okay. And finally, we did some practice problem also, depending upon the population. A question was discussed like the area of population is this much, per person is generating this much waste, so how much total waste is being generated. So these were simple numerical problem, but these numericals or these estimation will give a rough idea about design of upcoming treatment. In next class, in week 3 and week upcoming 4, dive into different treatment units like aeration tank, settling tank. So we will all the design of all that thing solely depend upon the estimation of these things, mis- on the value of this thing, how much waste is being generated, how much and waste generation is always dependent, how wastewater, the amount of wastewater which is being generated is always dependent upon the population of the area. Okay, so we will be looking. So I have some basic questions related to that only. So this was as in last class I have already told that I will be discussing. Actually, all the TA has been assigned to same task only, that we have been given some set of question. We have to discuss the answer of those question in detailed way, and you can expect those type of question in your assessment or in your final exam. Okay. So I will be coming. I will be going to the question one by one, and I will also request. Actually, only two people are there, but still you can participate. And I always recommend always encourage to ask you question. If you do not ask question, I will just keep going on saying something blah blah blah, not blah blah blah, but I will be on the track, but it will be a one way communication. So I hope, miss, I have assumed that you have gone through the lecture. So ask question. High chances are, miss, I will try to answer your question, but high chances are I might not also know what you are asking. Yeah, what uh, there are high chances that I might not answer also. So that will be a good experience for you also, for me also, because I am also a student. So I have not gone. It's not like that I am expert in this subject. Okay, now. So I recommend you, miss. I encourage you to ask question. So before going into the question, if you have any doubt, you can ask now, or you can always raise your hand, and in between you can ask. Yeah, if I am saying something, if you feel I am saying it incorrectly, you can always just raise your hand, yeah, or you can just unmute yourself and start speaking. I won't mind. Or you can just write in chat box. You have three options. Okay. So do you have any doubt? Yeah, should I go to the question? Okay, so I will be, I think, no response from you. So you have to be either you can say yes or not, saying this one thing is okay. Okay, don't worry about those things. But I hope you are getting what I want to say. Okay. So coming to the question number one, so I want you to answer this question. It's directly from your lecture hall, sorry, lecture video. Okay, na. So in your chat box you can write ABCD. Okay, na. So that will be good. Like that will be make. Okay, just this is read the question. The quantity of municipal wastewater generated from a city depends upon population of a city, water consumption pattern of the inhabitant, both population and the water consumption pattern, neither population nor the water consumption pattern. So if you have gone through the lectures, and it's very simple question. No need to know the. So C option has C option is correct. So this was very straightforward question. That was directly taken from your PDF or video lecture material that was given to you. So Yes, correct. And remember what is our final goal. Our final goal is to estimate the quality and sorry, quantity, how much waste. So all depend upon the population and all these things. So we have to know some basic definition. So keeping our target, that I have to finally design a treatment plant. So before designing, you have to know the basic things. So these question you can consider them as a basic things. So basic things. This question, obviously, these question are not tough or not tricky thing like ये क्या पूछ लिया, but you should know these things. Okay, so yeah, correct answer is C, that it depend upon the population and the water consumption pattern. So now suppose the more population means more water consumption will be there and more wastage will be there. Waste, generally wastewater is being produced in toilet waste, bathroom waste, kitchen waste. More population means more industries, more education, more commercial hub means there also will be more usage of water, and hence more wastewater will be generated. So that this is what I have written here. The population of the city, the more people living in the city, the more wastewater will be generated. Each person contribute to the total amount of wastewater produced through activities such as bathing, cooking, cleaning and using the toilets. Okay, and similarly water consumption pattern of the inhabitants means the amount of water used by the inhabitant directly affects the volume of wastewater. This is straightforward. Higher the water usage result in more wastewater. The more you use, the more wastewater will be generated. The water consumption pattern can vary depending on the lifestyle, climate, availability of water, and efficiency of the water use. So you can see like, and the more population, this is directly now you can just make a estimate, how much wastewater is being produced. Like when I was doing the wastewater question, a simple task was done that you can miss in brushing our teeth, how much wastewater we generate. So for that it was suggested that keep a bucket around 10-liter bucket below your tap, and in that process, and you will just see how much waste have you generated just doing your brushing your teeth. And you can interpolate that the water which is being generated by you doing brushing your teeth into other activity like bathing and all these things. So generally, it was estimated that for only for brushing our teeth, we produce around 5 liter of wastewater. Not 5 liter, but between 3 to 5 liter of wastewater. So that's why it is suggested that when you brush, keep your um, tap closed and all these things. So this has been, you can see these data on online also. Like you can just search how much wastewater we produce during cleaning our teeth or doing brushing. Okay. The answer is C, population of the population and the water consumption pattern. The question two is again a straightforward question. There are different options, that dry weather flow is. So again you can answer it. I think, oh, two people are there. Again I request you to go through the options A B C D and try to give answer. Dry weather flow is, the option is actual flow of the sanitary waste sewage, the storm contribution to the sewer in dry season, the combined storm water plus sanitary sewage flow, the quality of sanitary sewage flow subtracted from storm water flow. Okay, so just remember the hint is dry weather. They are talking about dry weather. Means there is no rainy thing, and also these two options will be can be, because they are talking about this storm water. If we are talking about dry weather, then why we are talking about storm weather? So B, C cannot be answered. One way, and then I hope you are getting what I am saying. So I am just giving you hint that they are talking about dry weather flow. Okay, so those select which one will be the answer. So, uh, Is today class problems or theory session? There are some theory. Five questions are numerical questions also. Like at the end of the session, I will be going through the forecasting thing, like arithmetic progression, geometric increase. If you have gone through the lecture, so there are five numerical question, five no seven numerical question, and 8 and 9 theoretical question. So this will be the session will be comprising of both things. Before I what initially I told you, like at the end of the session I will be estimating how much wastewater is being produced. But before knowing the before calculating the estimation, you should know that the basic things. So I, is it okay? If you miss see there are less number of students, so if you want I can just directly go to the numerical part. Will that be okay for you? Yeah, should I go, Miss? I have prepared around there. How many questions are there? Let me see. Miss, there are, I think 16 questions are there. Miss, okay, sir, what do? Should I go to the numerical portion or should I continue? See, up to lecture question number 10 I have theoretical question, then 13 is numerical, 14 numerical, 15 numerical, then extra there are two extra questions, and then last summary. I think in your assignment also you are getting this kind of question only. I don't know, miss. I'm not going through the assignment. I hope this is okay to you. If see, I am like right now, number of students are very less, so I am open to everything. If you will say that continue from here, I will continue from here. If you will say that go to the numerical section, I will go to the numerical section. No problem. So feel free. I don't know why you are hesitating. Only two we are only a group of three, so it should be it you should be more open. It's always good to open at, it doesn't matter how many people are there, but you can communicate. I don't know why you are hesitating. I'm not a professor or anyone to judge you that I will do anything. Be confident about these things. This is very serious matter that people don't know how to say something, what they want. This will directly or indirectly affect us in future. Remember, being a PhD student, I am saying you, if you are like shy like this, if someone is telling you continuously like puch lo, ask something, and you are still not asking, then it's directly or indirectly a loss to you. Okay, and considering this situation, I think you should ask question. I think we should miss. Okay, I should have given enough gyan. Last time I am asking, should I continue this thing or should I go to numerical section? Vishnu, just write in chat box, go to numerical section, yeah, continue this thing. Doctor is Vishnu. I don't know. Okay, so uh, I'm going to this dry flow. Whether the question was that you have to select the character, what is this? So basically, you should know that the okay, I will be continuing this thing only. So dry weather flow is the actual flow. So I will be going through one by one. So I have already said that they are talking about this dry weather flow. So B and C option can be neglected. So I will be discussing. I will be discussing each and every option. So the actual flow of this sanitary sewage. DWF means dry weather flow refers to the flow of wastewater that comes from domestic, industrial, and commercial sources in absence of any rainfall. As it is dry, that's why in absence of any rainfall. It represents the baseline flow in the sewer system that is not influenced by storm water. Okay. Uh-huh. So the miss you can miss without going to the other section, that is BC has been already miss rejected. So without going to option D, we can say the option A is correct answer. That the actual flow of the sanitary sewage which is there, like whether miss in absence of rain water and all this thing. Because see, if rain will happen, what will happen, that more sewage will come. But when we are designing, when we are planning something for dry weather, okay na, we will be planning our we will be constructing our treatment plant for all weather. It won't be like we have to we will be treating wastewater during winter in this treatment plant, and during rainy season in this we will be we will be constructing a single treatment plant. But what we can always check miss how much water should go in the treatment plant, we can control that. So we should have an idea of this dry weather flow, means when there is no rain, how much water will be coming to our treatment plant. Because we have to add some chemicals, yeah, add some, we have to do some kind of mixing and all these things. So it depends on how much water. So that's why they are talking about this dry weather flow. The stormwater contribution to the sewer in dry season. During dry season, there is typically little or no stormwater contribution in the sewers. So that's why this cannot be your answer. And the combined storm water, again same thing. It is talking about the dry weather, but we are talking, it is saying about rain water, but we are always talking about the question is concerned about dry weather season. But remember, we have to learn from this question, that why it is necessary to know dry weather flow, dry season flow, yeah, dry weather flow, anything. Because if we know the miss, if suppose in your in you have constructed a treatment plant in your area, okay na. So how much miss how much in water is coming during winter, and how much water is coming during summer, and how much water is coming in rainy season, that will help you to manage your treatment plant, okay na. Obviously in rainy season, the water which will be coming will be high as compared to dry weather season. So there are different treatment unit which you will see that require some kind of management. So depending upon the flow which is coming during different season, you can manage your treatment plant, okay. The answer is actual flow of sanitary sewage. The question is, identify the correct statement regarding design capacity of sewage system. The first statement is incorrect estimation of quality of sewage treated generally may lead to inadequate or hydraulic insufficient sewer system design. Underestimation of the design flow will make the system uneconomical. So select the, just to take 1 minute time. At the end of every question, I will give you 30 minute or 30 minute, no, sorry, 30 second to 1 minute to answer, to just go through the question, and I will start discussing. And you are always welcome to give answer in chat box, and at the end of the session you can see whether that answer is correct or not. Okay. So uh, I will go through the statement. This was also um, a straightforward question. First statement was the incorrect estimation of the may lead to, obviously if we are incorrecting the estimation, that will obviously lead to insufficient sewer design. So the first statement is correct, saying that an inaccurate estimation of sewage generation can result in a sewer system that is either too small or too handle to the actual flow, leading to the overflow or blockage, or too large, resulting in insufficient hydraulic performance and high construction and maintenance costs. So remember, suppose Suppose this is your house. This suppose this is your house, and this at the lower level, this is your treatment plant, and nearby there is a river and all this thing where treated water is being discharged. Okay, now. So now what you have to do is that you have suppose this is a residential area whole, the water from this street, all the wastewater from this plant is going to this treatment plant, and there are some internal sewage, one is coming from the here, one is coming from here. So now what you did that you suppose for particular area, suppose obviously we cannot we can always estimate overall estimation. Now suppose when you were designing this particular system, now suppose when you were estimating the amount of wastewater from this area, now what you did that you overestimated it. Say, so instead of you say you overestimated it, like in actual this was supposed to generate in future also, this was only generate to x amount of wastewater, x liter of wastewater, but in reality it is generating only 0.7x. Okay, now so you have overestimated it. So now what will you do that you for your design purpose, like for design purpose we will be using some equation, and in equation we will be keeping volume of the wastewater which is being generated. So as per that volume you have estimated, you will find that this how much diameter of the sewage should be there, how much length of this should be there, how at which places the manhole should be made, and all these things. So you will be doing this. So as you have overestimated it, so what will happen that there will be, you are wasting your money. If you have estimated it correctly, then there are high chances that you might not be wasting too much money. So that is another option. And the second option is, suppose you have underestimated it. Underestimated it means like it was supposed to be uh, in practical it produces x liter of wastewater, but you have estimated that only 0.7 liter of wastewater is being produced. So what will you do? And as you have estimated less volume, so your diameter and all this thing will be very less. Okay, now. So what will happen that as soon as the flow will come, as you have designed a sewage of very less diameter, so what will happen that it will block, and suddenly your sewage system will burst, or your drain system will broke down, and you will see wastewater in your area. Okay, so that's why this incorrect estimation will always lead to some default in your system. So this hydraulic efficiency will hydraulically inefficient means inefficient means so, uh, just 1 minute. I will hydraulic inefficient means like we want, like there are two options. Suppose this was our residential area, and this was our treatment plant. So I have two options. Either I can use one pump, a electronic pump, to pass all the water from my area to this treatment plant. But second option is, like we know that with the help of gravity the water may flow. Okay, na. So we can design our sewer system in such a way that without any mechanical help, like without providing any electricity, without the water, whatever water being generated here can can flow with the help of gravity only. That is gravity only, there is no need of external force. So that, and how will we will be causing some, you might have studied this in hydraulics, that if the L is, this is L, if this is L, and if it has height h, and it has height h1, and it has h2, then there will be hydraulic gradient between h1 and h2, that is h2 minus h1 divided by L, and depending upon that pressure there will be a pressure difference, and the water will start following. So Here we have to lay down our sewer system in such a way that we don't rely on the external pump to supply our water which is generated from here to there. The statement to underestimation of design sewage will make the system uneconomical. No, underestimation. I have already said you. Underestimation will never make it uneconomic. Uneconomical when we are talking about uneconomical, we are talking about wasting too much money. So I have gave you example that instead of you were producing only 0.7 x liter of water, but it has originality it has produced x. So you will be providing more surface area, more diameter, so that will be uneconomical because you are wasting too much money. Okay na. So that's why you said statement 2 is correct on miss. You can miss how you have think that statement 2 is correct. Sai Chandana. Just imagine now. Suppose there are two things like you were supposed to produce. You were supposed to make a sewage of only 1 meter dia, but you overestimated it and you make a dia of 1.5 meter. So which one is uneconomic? And in underestimation, what we do in our underestimation, we make a small I was supposed to make 1 meter cube, 1 meter dia sewage, but instead of that only I made zero point 0.8. So this is not uneconomic. It will cause problem. Underestimation will also cause problem like choking and all these things. These are blockage and overflow are the reason for underestimation, but that is not uneconomical. Okay na. So I think the answer will be statement 1 is correct, and while the statement 2 is incorrect. I hope you have understood. We are talking about underestimation, not overestimation. In overestimation we always do uneconomical thing. Overflow failure rather than overestimation will make the system had a confusion about. Yes. Okay. Okay, here it is written overestimation would make the system uneconomical due to unnecessary oversizing and increased cost. I hope you have got it. Coming to the question 4, design period of various sewerage components are usually based on. See, this is also useful question. Like these all are preparing for your final estimation thing, like how much you will invest in your investment and all this thing. Without knowing this thing, that suppose if you have not studied about this concept of overestimation and underestimation, then there are high chances that you estimated something. First of all, that is during estimation, when we will be looking into estimation, at that point also we took some assumption. We are always miss some, we are taking some factor like this much factor, like suppose it was supposed to be like from x to, suppose population was going to be 1 lakh, from 1 lakh to 1.5 lakh, we have estimated that 1.5 lakh, but we are not sure that at the end of 10 years the population will be 1.5 lakh. We have just estimated it, and we, whenever we estimate it, we always take some assumption, and in that assumption we make sure that we are not neglecting anything. Okay na. So in, apart from estimation, you cannot overestimate the things. Overestimation will always cause some problem. Okay na. So design period of various usually depends upon. Go through it and try to answer it. The availability of design, funds for design, useful life of a specific components, duration of the sewage service required, average life of a uh, sewerage facility. Okay, I will be going through one by one. So the availability of average fund. This option is incorrect because why it is while funding it is a crucial consideration in the planning and construction of sewage system. It does not directly determine the design period of the components. It does not obviously how much money is with you will not account into design period. If you know the design period, you can always find, yeah, you can always demand the money that this much money we want, but depending upon the how much money, you cannot estimate that how for how long we can, because every instrument has their own functioning. It does not depend upon the money. Okay, the useful life of the specific component. So this is useful, like for a every component. Suppose you are using your mobile. Every mobile has a specific lifetime, whether it doesn't matter how much money you are spending on that mobile. Every mobile have some specific time period, and after that that mobile will won't be workable, yeah, won't be useful to you. So but in I hope you are getting. So this was also a straightforward question that this option, the design period is based upon the expected useful life of a sewage component, ensuring they remain functional and effective for their intended lifespan. Okay, now so we will be designing, like suppose we are talking about filtration, and in filtration we know that this component. Suppose I'm just giving a rough estimation. So suppose that filtration system will run for say 20 years. So we can say that our treatment plant will be for 20 years and all these things. So depending upon that, we will be investing money and all these things. Okay, now duration of the sewerage service required. This option is not specific, though. While the duration of service is important, it's typically considered within the context of useful life component rather directly determining the design period. So this is also straightforward. Average life of sewerage facility. This is option partially correct because less precise than option B. The average life of sewerage facility can influence design consideration, but the useful life of individual component is more directly factor to determining their design period. So we always depend upon the individual things, not like, I hope you are getting it. The average life of a sewage facility can influence design consideration, but the useful life of individual component is more direct factor in determining their design period. Till now, if you have any question, you can just ask. Because right now I am just doing one way thing. Question number 5. This is again, now you know the basic things. Now you have to forecast, like how, forecast. So for forecasting, there are different method, and different methods are being used at this has been discussed in your lecture also. So different method is used in different condition. You have like four method has been taught to you, that is arithmetic increase method, incremental increase method, geometric increase method, and logistic growth method. So and each method should be used for a particular area. You cannot use every, and you have to miss, you cannot decide. So depending, there are some, for each method there are some condition, and depending upon that condition we can use that area. So the he is asking that which of these population forecasting methods you like to estimate the forecasted population of city of a moderate size and age. Moderate size means that area is not that area is, the area of city is not that large, and the that city is not also old, like has been recently not, but like the establishment of that area has not been so long. Like some area are very old area, like you can just always see there are some places which are considered to be very old, but some small portion, some area which might have been started to see some activity maybe in last 100 years, yeah, last 200 years. So you have, or maybe 20 years also. So which method we will be using. So all the different method are basically dependent upon the moderate size, means how large is that area and how old is that area. Okay, now so I will be going through one by one. So first is arithmetic model. So this method assumes a constant absolute increase. Arithmetic means, you can see that arithmetic means adding anything. So it assumes that there is a constant increase. So this method assumes a constant absolute increase in population over each time. It's generally used for city with a stable slow growth rate. This tends to underestimate population growth in a rapid growing cities. Okay, now. So you can see that arithmetic is used for a stable city, which is very stable, and the growth period is not, there is slow growth rate, because uh, in past maybe 5 year or 10 year or 20 year, the growth has been very constant, a very slow growth, from 1 lakh to 1.1 lakh, then 1.1 to 1.2 lakh. So the growth is not so large. Okay, now. So in that area we will be using arithmetic increase method. If we talk about incremental increase method, this method consider increase population is not constant but increase by certain increment over each period. So in arithmetic when we use, like when it is increasing from 1.1 to 1.2, 1.2 to 1.3, maybe in last 5 years, so we are saying that there is increment of only zero point 0.1 lakh. But when we see that for a particular area, the population is not constant, but increased by a certain increment over each period time. So generally in India, we do census after 10 years. Hope everyone is know. So we will check for the last 30 years data, and we will see how the trend of that area is there. Depending upon that, we will look into it. This method accounts for change in growth over time, but can lead to overestimation if increment are high. Okay. Sorry. This method assumes a constant percentage growth, which means population grow exponentially. For city moderate size of age, this method is like to overestimate the population, as it assumes the growth rate remains high or over the time. Again, here same thing. We see there are some numerical equation for all these method that I will be discussing in question number 11. But just for right now, just go through this numerical thing, the theory thing. Okay. And then we have last logistic growth method. This method considers the population growth will start slow, rapidly increase, and then slowly slow down at reaches a saturation point. So what will happen, that suppose if for a particular area, this is generally for newly constructed, the city which has been people has started to migrate recently. So what will happen, that suppose there is an area, so initially, and a particular area has a particular limitation, that it will accommodate this much amount of people. So what will happen, that initially there will be slow growth, but suddenly as more people are coming, so there will be two things. There will be more, as more people are coming, it will be opening maybe it will be opening a commercial thing or anything. So again more people will start coming, then internally there will be a reproduction and all these things. So suddenly there will be, what will happen, that there will be a growth in population, and but after some time the growth will stop, because it has reached a saturation limit. Okay, now. So if some data show that for a last say 30 years or 40 years, this trend is being followed, then we say that logistic growth has opened. Okay, now. This is most, so I hope this is clear to you. So depending upon the all option, we can see the geometric increase method, which was asked for a city of moderate size and age. The geometric increase method will be suitable, because this is for uh, slow, is like uh, a stable, means very old city, for very old city and all this thing, there is no much more increase in population with time. Then this is for this is random thing, like we don't know, if we don't know anything about that particular area, then we, because increment, there are high chances that increment is due to reproduction within the city, or there are some kind of migration and all these things. But here we are seeing that there is exponential growth, means with time there is some increase. It's not randomized, yeah, we are not seeing a constant pattern. So we are seeing that there is increase, but it's not constant also. So so that can happen only in a city with moderate size or particular things. So answer is C. Hmm. You The sixth question is, using growth composite analysis method, that is demographic method, population is estimated based on annual birth rate, death rate, and migration rate. Which of these is relatively the most difficult to estimate? So when we are estimating this population, we generally account for annual growth, like how much annual birth rate is there, how many people are taking birth in that particular area, how many people are dying. And they obviously, due to now, suppose for a particular area, it has become economical hub, yeah, yeah, commercial hub, then obviously the more people will start coming to get a job, you have to do some work. So obviously this is called migration, that from particular area some people are shifting to that area. So which thing we can estimate very easily. So this is also a direct question. Birth rate, we can obviously go house to house, we can see, we can, based on data, we can estimate the birth rate, we can estimate the death rate also. But we cannot estimate the migration rate, like how much people are coming for a from particular to particular area, from where, we cannot estimate that. So this question is also direct question, that migration rate, estimation of migration rate is very difficult. Okay. The birth rate generally can be estimated with a fair degree of accuracy using historical data and trends. It is relatively stable and predictable over time given the constant healthcare and social condition. Death rate, like the birth rate, death rate can be also estimated with reasonable accuracy using historical data, medical advancement, and trend in public health. It is typically more predictable than migration rate. But when we talk about migration rate are most difficult to estimate. The migration is influenced by a wide range of unpredictable factors such as economical opportunity, political stability, natural disaster, social condition, and government policies. These factors can change rapidly, making migration rate highly variable and challenging to predict accurately. So I hope this is clear to you. So migration rate is very difficult to estimate. The peak factor, you might have studied about the peak factor, like at a particular peak factor is used to estimate the peak of a sewer design. The correct option between the peak factor for sewer estimation with increased population is peak factor. I hope you might aware what is peak factor. Like for a particular, like suppose in a day, this there is a treatment plant. Suppose I am talking about a particular day. So what will happen, that say we start at 12 p.m, 12 a.m night, and we will end at 12, we will ending at 12 night. Okay. So what will happen, that initially there will be the flow which will be coming to the wastewater will be very low, very low, very low, very low. And again, as soon as it's 6 p.m, 6 a.m, so what will happen, that there will be increase in volume of the wastewater, because people has people has awaken up. So they have started to go, they have started to make food, so started to go office, so they have to take bath. So there will be increase in volume, and suddenly at 6 p.m everything will be again normal, because people have gone to a schools, college, work. So again what will happen, that we will see the decrease in trend in wastewater. Again at night 6 p.m, again we will be see that high people have returned back. So what will happen, that at this time, that is around 6 p.m, maybe around 8 a.m, and similarly at 6 p.m we will be see increase in wastewater. So this will be considered as a peak thing, because we are getting too much water at. So there is particular definition of peak factor. I don't remember the definition right now, but I'm seeing that I am uh, miss depending upon the highest amount of wastewater that is coming at a particular time. it somehow relate the peak factor. So I will encourage you to go and look into the definition of peak factor. Okay now. So I have just given you idea, I'm not saying any kind of definition and all these things. So this will be considered as a peak factor. This will be considered as a peak factor for this treatment unit, because at this time they are getting highest amount of wastewater. Okay. The peak factor is used to estimate the peak flow rate in it accounts for the variability and fluctuation in sewage. We see that because when sewage flow is coming, there is fluctuation. In morning there is no, then again at night at for particular time huge amount of wastewater is coming, and again at some point there is no wastewater, and again at some point there is, so there is a fluctuation. Ensuring that sewage system can handle the maximum escalated load, so you have to design obviously what is happening that as your wastewater is flowing through the sewage, so it has to be designed in such a way that it can handle the maximum load that will be coming during peak time. So if factor is somehow again I'm saying I don't know the definition of the peak factor. So at that point the huge amount of water will come, and so we have to design in such a way that it can handle the water coming at this uh, uh, water coming at high level. Okay na. So the question is the option are peak has fluctuation for highly populated area, fluctuation independent of population increase, typically increase with increase in population. Peak factor typically decrease with decrease in population. As population increase, the relatively variability in sugar tends to decrease. In a smaller population, individual behavior activities can be cause significant fluctuation in flow rates. However, in large population, this variation tends to even out due to averaging out of many users, resulting in a more stable and predictable flow patterns. Consequently, the fixed factor which account for this variation tend to decrease as population increase. Now, suppose whatever I was saying. Now, suppose miss this was for a small area, like there were 100 people in that area. So obviously, every 100 people will have this tendency. Remember, this is very tricky thing. Like generally people will say that more population, more peak flow, peak water, because at 6 p.m. everyone will awake. So this is true for a small area when we are seeing for 100 people. But now you are looking at lakhs, maybe lakhs, or maybe crore. Suppose one area has a population of around 2 lakh or 4 lakh. Okay na. So there will be some population which will wake up at 6 a.m., but there will be another set of population which wake up at 8 a.m., and suddenly there will be another set of population which will awake at 10 a.m., 10 a.m., 12 a.m., and according to that there will be a production of wastewater. So you can see that there will be some time there will be low water, but as it has increased, but it has not increased so much where there was population was very high. So and the increase is not so high, so it has somehow fluctuation is very low. Like it has consider this for particular, what will happen that is why there has been certain increase. Again you can see the increase is not so high. Again there has been some increase, again the increase is not so high. And you can see it is happening throughout the day. It's not like for particular time period there is high, but for higher population it is observed that for a particular time period too much peak, again no peak, and again at maybe evening or after some time there will be some peak. So remember this is kind of tricky thing. Like you cannot say that more number of population, more peak, higher peak, because there will be several kind of people, and every people will follow different trends which we don't know. For a smaller people we can say that these are 100 sets of people, they awake at 6 p.m., they generate wastewater at this time, and so on. So this is what is written here. However, in a smaller population, this variation tends to even out due to averaging effect of many users, resulting in a more stable and predictable flow pattern. Okay, the many users are there. Consequently, the fixed factor which accounts for this variation tends to decrease as population increases. Okay, again, hmm, Population forecast in a logistic growth model is limited by. Okay, so I think when I was discussing about logistic, I told you for there will be like uh, there every area has a particular population carrying capacity, so there will be increase, and after some time the population will constant, means no more people can live here. So this method is known as logistic growth model. So you can answer directly this question. Okay. Hmm. The population carrying of the region. Obviously, I can say that every particular region has a maximum. We cannot add as much as people we want. Okay, now. So I will just show you the trend, how logistic trend works. Okay, now I have pictures. Huh. Oh, in next slide only I have this thing. Okay. So you can see that this is logistic growth model. So initially, when hmm, initially when population was low, the growth was also low. You can see less population, less growth. But as soon as with time, due to maybe due to economical hub, due to business thing, or due to government policy, and due to birth rate also, the population has started to increase, and all of a sudden once this rate has come, the once this rate has increased, the population has shoot up. And but that area will have a particular population that will have a carrying capacity. So that's why see, every area has a particular population, limiting capacity, carrying capacity. If when we are talking about this overpopulated area, so if that area means if that area has crossed this carrying capacity, then we consider this that area as overpopulated. Yeah, is overpopulated, yeah, more populated. You might have seen that India is overpopulated and all these things because it has crossed its limiting capacity. It has, means I don't know exact number how much people should reside in India. I don't have no idea about that, but you can always go and search what is the carrying capacity of India. Currently we are 1.4 billion people, 140 crore, 140 crores. Okay, na, so you can just go and check. So this is a trend of logistics. So if some data particular data for last 100 years is following these trends, then we see that there is a logistic model for growth population. Okay. the co- hmm, the question was this thing. So the logistic growth model is designed to reflect how population grows more slowly as it approaches a maximum sustainable size, known as carrying capacity. So initially the growth is slow, but again it has boosted up and it has reached the carrying capacity. This model takes into the account the initial exponential growth phase, but then incorporates a declaration phase as resources become limited and the population nears its near it carrying capacity. The carrying capacity is the maximum population size that an environment can sustain indefinitely, given the food, habitat, water, and other resources available. Therefore, the logistic growth model inherently limits the population forecast method on the carrying capacity. I hope this is okay to you. So this is like uh, uh, logistic growth population growth. This is how trend is seen. Then we have this arithmetic method which we have decreased, where the rate of population is proportional to some constant. Then we have geometric increase method, where the population is proportional to current population. Okay, that is dp by dt is equal to k2 into k. Then we can integrate it. Yeah, we can solve this differential equation. We can find the we will be generating the equation also in upcoming question. Okay. Then we have decreasing rate of increase method. Yeah, logistic growth method which we are talking. So this is also decrease another method of estimation, which you, I think this method has not been covered. I have taken this slide from my lectures that was taught to me. I think this was not in your lecture. Okay, now there was incremental method that we will discuss in upcoming slide. Okay, so again we have CPHO manual. Okay, now it will be 2012, not 20212. Just let me check which CPHO is there. See, whatever we are doing, we are following one manual, and that manual is from 2012. Okay, na. So whatever, like whenever for a particular area, when we are designing any sewage, then we have to look into this manual of sewage and sewage treatment. Okay, na. So this is uh, uh, where did it go? So this is known as CPHEEO manual. CPHEEO manual, and full form is I forget the full form. What is the full form? Central Public Health and Environmental Engineering Organization. This is a organization which provide everything about the treatment, how for designing. There are several criteria. Uh, there are several criteria. Option D you have said. Option D, no. Option D is not correct answer. 100 liters. C option is correct. So this is written here that how what should be the minimum. I don't know on which page it is written, but it has said that a minimum flow should be this much for sewer design. Okay, now so it has like, see, uh, you will study, I think, how much flow should be there and all these things. This means this is like a standard code thing, like it is a kind of a manual only, so you have to follow. Whenever we are designing something, when we are looking into something, we have to follow this, or whatever the thing is being written here, that is known as CPQ. I think the question is being asked for 2012, so that's why I have downloaded the 2012 manual. But there are, I think there must have been some modification also. Okay, now so just let me search for one. That is a problem of IIT Net. I don't know. But you can see that what is the latest trend. There must have been some change in this pattern. There, mis changes are not so much significant, but as population are increasing and all these things. So see, oh, it is also old one. So you can always go and check which one is the current manual which is being followed. Okay. Hmm. So, as per the CPHO, the conventional sewage should design for a minimum sewage of 100 liter per capita per day, like per person. If you miss now, miss, like it has said that now depending upon the, this liter, this population. If say if you are given a task, suppose in exam, yeah, some task has been given to you, design for a minimum flow, how much diameter should be there, given that the population of that area. So you will be multiplying this volume into population, and you will be knowing that this much liter of per day is coming, and you will be giving some other parameter also, and depending upon that you can find out what should be the diameter of that sewage and all these things. Narayan, please turn off your mic. Hello, please turn off your mic. Oh, thank you. The hija. Hmm. Huh. So again one question: which of these may lead to additional inflow to the sewer lines? Like so, first understand the question. You might have understood the question, but suppose there is one house, the sewer line is going on, and it is going to treatment plant. So he is asking. The question is being asked that in this pipe, which of these option will, apart from the waste which is coming from your house, apart from house, which other amount of water will be considered as a inflow in your sewer line? Okay, now. So consider like let's see. I want you to answer this question. Which one will be AB out of ABC? Which one will be correct? Please write in chat box. Option D. Someone has said option D. But now imagine the water which you use in gardening. How that water will go to sewer line? Suppose this is your garden. That will be what you have used. That will be used in your garden. That won't flow to the sewer line. That has been taken up by your plant and all these things. So how that will be in your sewer line? So so this cannot be answer. So all of the above cannot be also the answer. Now we have option A and C. Are you getting what I am saying? I hope you are getting it. So gardening water we use very small amount of water for gardening. Like, but that water is being used by gardens. It is not creating any kind of flow that will be passing through the sewage. So option B cannot be, and option D also cannot be. So other come is water losses from water supply system. So obviously there is always two supply in your home. One is which is being provided to you. Now suppose there is a leakage and all this thing. There is some leakage, so the losses, the water losses from water supply are due to leakage only. So those leakages are very low. What happened that they generally, this will be considered as a water loss. Means the loss will be not so high that it will now go in sewer and it will do some kind of additional flow. So it won't be any water losses from this, cannot be your answer. Water used for unaccounted private water supply. So this will be like there are some unaccounted private water supply, like there means like there are some private farms and all these things. So where, so maybe say industry and all this, industry and all this thing. I'm just giving one example. So water from this, whatever water being used from this here will be also added to the your sewer line only. So this will be your answer: water used from unaccounted private water supplies. Like maybe you doing estimation, yeah. Why they are saying unaccounted water supply? Unaccounted means you have not considered those things, but still they are there, but and they are producing some amount of water. The household using water tube etc discharge for additional municipal water usually do not reach sewer. So this is what I have told you, that the water which we use for gardening does not reach your sewer line. Okay, now household using water from tube tails, etc. Okay, we know that the water is being used from these places only. Discharge additional sewage to measure etc. Household, apart from some additional, suppose now what is happening that you, in your house you are collecting in your tap in your bucket you are collecting some water. Okay, so what will happen that that water, suppose you have used, you needed x amount of water, but now you have overflown and all these things, so that will be also considered as a unaccounted water supplies, which will directly go to the sewer line and all these things. Okay, the household using water from tube wells, river, lakes, private boring, etc., discharge additional sewage to municipal sanitary system. I hope you are getting it. Now, I want you to solve this question. So first question is like, there is one village whose last 10 year last 5 decades population is giving that in 1970. Consider this is like random data, not consider as a random data. In 1971, 447 population was 447. In 1981, the population was 574. In 1991, the population was 724. Now you have, and in 2021, the population was things. I miss. Please note down this data, and else I have to. There will be some sets of question. There will be 5 sets of question related to this problem. You have last 5 decade data. Now the first question is, calculate the projected population of village for the area 2023 using arithmetic increase method. Okay na. So this I am also giving you the equation which is required to solve this question. That is dp. We know that for the arithmetic increase method, dp by dt, that the rate of population increase will be constant and it does not depend upon the population. So after integrating and putting the initial value, we come to know that for n decade the population will be p naught, that is last known population, plus n into means after for how many number of decades you want to know the population, and in the average of that area. Okay na. Remember, ha remember this n and this n is not same. Okay na. These are not same. The n which is written here is the how much data you have. Okay na. That is, I should have given some other symbol, and I think this is, I don't know whether I will be able to change it or not. No, this is a picture, so I cannot change it. So I apologize for one mistake, that this n and this n are not shown. This n is representing number of data. So I want you to calculate, everyone. Please note down this data and calculate using arithmetical increase method. Take time and please in the I want everyone. There are 5 people. Please solve this. This is very simple question. Only we have to do some numeric calculation. We have to find first x bar using this data. This will be the summation of this plus this plus this. There are total 1 2 3 4 5 data. So this summation of this divided by 5 minus 1, that is 4. Then we will finding x bar, and then here we know the last known population is 10307 plus n. We have to find after how many decades we have to find the population. So that is after see the last population, last data was 2011. So and we have to find the population in 2023. So one decade will be 1.1 2022, and again after we have to find 2 years after, then the whole decade will be 1.2 decades. So this is what I have done here. So this was my data. This was my data. Pn is equal to p naught plus nx bar, where p naught is 1307. The average is 217, that is summation of 127 plus 150 plus 250 plus uh, sorry, I have missed one thing. Sorry, big mistake. So there, when we are writing x bar na, we are not directly taking the average of the population, we are taking the average of increase of the population, okay na. So here see, this the data which is written here, it is it is a data of population, that is 447. This is population, so you have to take the average of increase in population. So this is what I have done. So from this year to this year, there has been increase of how much increase has been there. From 447 to 574. So there has been increase of 127 population. Again 720, from 724 to 574, then there has been increase of 150 population. Similarly, from 947, from 724 to 947, then there has been increase of 250 number of population. And again from here to here, there has been increase in 330. So this x bar is the average increase or decrease. Remember, initially I did not mention it, that what is this x. X is average increase or decrease. There might be there, you might be facing question where the population, there has been decrease in population. So again you have to take the average. You have to find how much increase or how much decrease has occurred, and you have to take the average of those data. Okay na. So here from 447 to 5, there has been increase this much. So we are taking the average of 112 plus 150 plus 250 plus 300 divided by 4 5, because we have 1 2 3 4 5, 1 2 3 4 5 5 set of data. So n minus 1, which I've said, and n minus, no, suppose say that as m minus 1, okay na. Hmm. So the x bar will be the average increase or decrease, that will be 250. So n is equal to 1.2. The overall population in 2023 will be 1007 plus 1.2 into 215, that is 1516. Sorry, 1565. I hope you have, you miss, this is clear to you. I have I just somehow forget to mention it, like the x will be in average increase or decrease, okay na. So you have to calculate x, then you have to take x bar. And how you will be calculating x you will be calculating by taking the average of all these things. Is this clear to you? I am assuming, so now second method is that calculate the projected population of uh, village of 2030 using, again I have made one mistake, not, I don't think here I have made any mistake, huh? So I have here, see here I have used m, okay na. So in this question also, this will be m, okay na, m minus 1. N will be number of decades and it will be m minus 1, and it will be xm. Please correct it. Okay, so now everyone please solve this, take your time. You have to find the under root and all these things, use your calculator. And here you can see that I have written R, how you will be calculating R1 and R2. So here I did not mention how to calculate x1. X1 I have said, see, x1 will be p1 minus p0. So first you have to calculate x1, then you have to take the average of x, that will be x bar. Similarly here you have to first find r. For finding r, you have to find r1 r2, and r1 r2 will be find by p1 minus p0, that we know that x0, and divided by initial population, and it is number of decades. Here number of decades is 1.2. Everyone please solve it. Hmm. So here is the solution. See, first we I have calculated x, that is 120 127, 150, 250, 300, and then we have I have calculated R. For R, what I have used? R, I have used the formula, mm, this formula, that is P1 minus P2 divided by P naught, that is X naught by P1. Just focus on this formula, okay now. So this minus this, that is 127 minus 150, yeah, 150 minus 127 divided by 127, and that will be 28.41. Similarly for this turn, 250 minus 150 divided by 150, 250, 330, this divided by this divided by in this value, okay now. So from here, huh, sorry, remember, again I have made one blunder mistake. It will be 150 minus 127 divided by 447. You can check on calculator. Please check this by yourself. Just let me open my calculator. Because the formula is P1 minus P naught divided by P naught. Okay na. So that is 527 minus 447, that is 127 divided by 447, that is 28 point, 447, that is 28.41 into 100. You have to multiply by 100 also. Are you getting it? Sorry for the confusion, but the R1 will be 574 minus 4 4 7 divided by 4 4 7 into 100. If you do not multiply by 100, there will be not any problem, but in the formula, then you don't have to divide by 100. Either you can here divide by 100, or you then you have to multiply by 100 here. If you are not multiplying by 100 here, then you have to remove 100 here also, okay na. But I hope you are getting it, okay na. Similarly, R2 will be 724 minus 574 divided by 574. At the end here it will be 1307 minus 497 divided by 474, sorry, 974. You can just let me confirm, 1 7 974, uh, 74 74 divided by 974, you can say 34.19. Okay, I hope this is okay to you. Then I will be finding the average increase or decrease. Then average increase or decrease will be calculated by this formula, r1 r2 into rm की power 1 by m, and m will be here 1 by 4. Okay na, that is this multiplied divided by 1 by 4. So n will be, and n we know that it will be 1.2. Then p average will be there. See, now here you have two option. Sometime what happen, uh, so I hope you are getting it. From this estimation we got from p2, the population in 2023 will be 100,108. From arithmetic mean I got the population will be 1565. Okay, I hope this is clear to you. Is it okay? So now last option is, last method is incremental increase method. Here the incremental increase method, the formula is given by Pn is equal to P naught plus n x bar, n into n plus 1 by bar divided by 2. P naught is last known population, x average increase or decrease. Here again it will be m and m. Okay, x1, and by will be x2 minus x1. Okay na. So here your m is how much? M is 4. Sorry, m is 5. So again here you can see what I have done. First I have calculated x. How I have, again same thing, that this minus this minus this minus this minus this minus this. And for calculating by, I have done 150 minus 127, that is 23, 150 minus 1 250, 250 minus 150, that is 100, 333 minus 250, that is 83. And I have taken average of that thing, that is x bar has come out to be 215, and y bar has come out to be 680.67. So here the I will be substituting all the value, that is 1307 plus 1.2 into 215 plus 1.2 into 1.2 plus 2 divided by 2 into 68.68, yeah, 67, typo mistake. And the final population will, you have to always report the population in numerical method, that is 1656. Okay. So I hope, see, these question, if you are in your normal exam, this will be asked. If you are preparing for gate, I think gate, huh? Gate also, I think, I'm not sure, but I think in past they have asked question related to this. So these are very scoring question. We have to solve it. Just you have to keep in mind how to calculate x and y and all this. Generally, people ask question related to this incremental increase method only. Okay. So the coming to the 14th question. A city with population of 100 lakh population, to sorry 100 lakh 12 lakh population receive itna liter per capita per day. See the unit is means LPCD means liter per capita per day. Okay na, 150 liter per capita per day. Assuming that 80% of the water means, suppose consider this is a house, this much water is being supplied, and it is saying that 80% of the water use is received as a municipal sewage. Okay na. So what is happening, that they are saying that whatever the water is being supplied, 80% is being generated as wastewater. And there one more information, that maximum daily flow of the sewage from the city, assuming a daily peak factor of 2. So I have already said that, miss, there will be a peak factor. So considering that peak factor as a 2, because we don't know at which point this huge amount of water will be coming, but they have estimated that whatever be the normal flow, at the peak time, the peak factor is two times than the normal flow. That's why they have given a peak factor of 2. So whatever means water you will be discharging, it will be multiplied by 2, because at the peak factor you are in your sewage, two times more, 2 times more water is going. So you have to prevent any kind of blockage and all these things, so you have to design in a such a way. So this is a very simple question, that what will be the maximum daily flow of the sewage from the city. Again, take your calculator, copy pen, and try to answer it. Very simple question. You have to multiply everything, and you have to see the unit is mld means 10 ki power 6. Lakh means, you can just calculate how many zero will be in lakh. And I have already said that per capita means per capita, liter per capita per day. You have to report answer in million liter, that is 10 ki power 6 liter per day. Huh. So you can see that every population into per capita, that is one this much population is 12 lakh, that is 12 into 10 ki power 5 lakh to 12 into 10 ki power 5 into 150 liter per day. See the unit, you can see the its unit was capita. It was liter per capita per day. Capita cancelled out, that's why they have just written liter per day. Always try to match your answer in unit. Okay na? So when we multiply it, it will be 180 into 10 to the power 6. 180 180 into 10 to the power 6. They have converted 10 to the power 6 into million, so that's why they have written 180 million liter per day. And they have said that this much water is coming, but 80% is being converted into wastewater. So 180 into zero point 0.2, that is 144 mld water is being going as a wastewater. And they also say that peak flow is uh, uh, peak factor is 2. So the your maximum daily flow will be 2 times into 140, that is 288 mld, 288 million liter per day of water. I hope this is clear to you. Again, one short question and easy question. Here also you have to take account of unit, that daily daily sewage flow from city is 160 mld, 16 mld, that is 16 into 10 to the power 6 liter per day. Assuming daily and hourly peak factor as 2 and 2.5, the maximum hourly flow of the sewage would be. You have just remember, here you have to convert, you have to look into unit. Just one hint is that uh, 1000 liter is equal to 1 meter, million liter per day. MLD means million liter per day, million liter per day. And one, that's why here also you can see that I have written 180 into 10 to the power 6. 10 to the power 6 means how much? That is 1 million. So they have written 1 10 to the power 6 as 10 lakh, 10 lakh, yeah, 1 million. Okay na? So million liter per day, this much means 10 to the power 6 liter per day of water. So instead of saying this huge number, they just say as a million, MLD. Yes. So one is 10,000 liter is equal to 1 meter cube. Okay. So here it is saying 16 mld. 16 mld means 16 million liter per day. 16 liter means 10, 16 into 10 की power 6. This is million liter per day. Okay. Solve this question. Hmm. So we know that average flow is given as 16 mld, and the maximum daily flow, that is it is daily peak factor into average flow, that is 2 into 16. Okay. The hourly average hourly flow on a maximum day will be 32. So here you have to look into the units. Okay na? So this is set of formula. This is like, this is not made up things. So I am guessing that I want to be going into detail what is this, how to calculate this daily flow into every sorry. So this daily peak factor, if you multiply daily peak factor into average daily flow, you will get maximum daily sewage flow. So average daily flow has been given to you 16, that is 32, and peak factor has been given to you. So maximum daily flow is 2 into 16, means average daily flow, whatever the average flow is there, the peak at the time of the peak time, it will be double that thing, that is 32 mld, that is 32 million liter per day. And the average hourly flow on the maximum day, that will be 32 into this. See, they have converted, how they have converted into, now they are writing 1000 meter cube. So how they have written 1000 meter cube? So they have converted million into 10 ki power 6, 10 ki power 6 liter. So it will be 10 ki power 3 into 10 ki power 3 liter. And they have said this 10 ki power 3 as liter as meter cube. So they have written as 10 ki power 3, 10 ki power 3 meter cube. So now you know your uh, uh, see, this was per day. So now you have to calculate hourly. So hourly will be 332 into 1000 meter cube divided by 24 hour, and because one day 24 hours. So this much hour. This is hourly peak flow. So now till now till now we were talking about this daily peak, like in a day. Now what will happen that if we reduce our time, like now we are talking about for a particular hour, so for particular hour, obviously for in a particular hour there will be a certain time where there will be high peak. So out of daily average maximum, out of average daily average flow, there will be some peak hour also. So and that factor has been given to you 1.2. Do not get confused why we are multiplying two times. One first time we are multiplying to get what is the maximum daily flow. Okay, now once we got the maximum daily flow, we are converting that into average, hourly average, by dividing by 24. Now we have to find the maximum average hourly flow, that is peak hourly flow. So whatever be the maximum average, whatever be the average hourly flow, we have to calculate, we have to multiply by peak factor to get our maximum hourly flow on a maximum day. First time we are talking about whole day, that is 24 hour, means 24. Imagine like this, whatever water has been flow. So there now like overall, suppose you say that initially there was 0 1 mld, at evening it was 5 mld, at the night it was again 1 mld. So average you will take off, if you averaged, if you have taken average, so overall it come out to be say 16, uh, say 16 mld. Okay, this was daily average flow. But but you remember, but there was one time where their flow was very high. So how you will find that maximum flow, that is being considered as a peak flow? So for to find for a particular moment where there was maximum flow, you will multiply it by the peak flow, peak factor. Okay, now so whatever be the average of the complete day, multiply by that peak factor, that will give you the maximum flow of that day. Okay, so you have considered, you have multiply, you have found out that thing. Okay, now that you have found the maximum daily flow from the average daily flow. Now you know the maximum daily flow. Okay, for that particular maybe it might be, it might have happen at any hours, you don't know. So but you now you have to find the maximum hourly hour. Now instead of 24 hour, you want to focus on 1 hour, at which, at there will be at some point, there will be some particular hour where this flow might be have been actual. So what will, so from this, so from this maximum daily flow, you first find out the average, means hourly average. What is the hourly average on that maximum day? Okay, so that we have done by dividing by 24 4 hours. Then we come out to be this number. Now we know that uh, now for a particular hour, you have taken reading at this minute, and overall average come out to be this much. So at a certain point, must have reached at a certain peak. Okay, now so to find out the maximum flow of that hour, you have multiplied the peak factor of that hourly peak factor. So from there we have come out to be peak hourly, maximum hourly flow on the average day. into the peak factor, that is 1.5 into 133.3 into, that will be nearly 2000 meter cube per hour. Remember this conversion. Do not get yourself confused why we are multiplying two times. One, at first time we are talking about complete day, then second time we are only talking about a particular hour. Okay. So I have two extra question, and we are also out of, not out of time. We have around 50, 10 minutes. Method. So see. So um, when we are designing something, we have to choose. When we are estimating, we have to be like we have calculated population from three method. Okay now, so now I have to choose that which method should I use for my design purpose. So every area, yeah, everything is every manual. Suppose there is manual that say that you have to design for this much growth factor. Okay now, the method which has growth factor now, depending upon, I don't know the criteria to choose the growth factor, but for right now I am just giving you one imaginary situation, like you found one manual. Maybe I'm not saying that this might be written in CPHO, but you have found some detail that for designing the treatment plant for this particular area, you have to choose a ratio of between 1.25 to 1.3. Okay now, to be selected for forecasting which of the following method has the growth ratio in this range. Okay now, so in 2023 you have estimated this much population, and in 2012 this much population was there. So you found out the growth ratio, that what is the at 2023, and what is the 2023 divided by 2012, that is 1565 divided by 1307, 1801 divided by 1308, and 1656 divided by 13, and you calculated the growth rate. And that manual has said that you have to choose a growth period of between 1.25 to 1.3. So you can see that this 1.27 come in between 1.25 to. So for your estimation, for your design purpose, you will be choosing this population, that is 1656. Did you get it what I said? That obviously you cannot, means you have to choose now for design purpose which population you have to choose. So that depend upon the growth ratio. Like for design purpose you will be given you have to choose this much growth ratio. So for like in this question, like they have given me that this much is the growth ratio. So you have to uh, hmm, you have to, for your treatment plant you have to, this growth ratio will say that yes, this population, forecasting by this method, you have to follow the forecasting by this method. Okay. This question is not related to this question is not related to this wastewater. This is related to water demand, so ignore this question. And last, the summary of the population growth. This is not also. Uh, I think I have covered most of the things. So we have, how much time we have left? We have we deleting these two slides. So we have around 10 minutes. If you have any doubt, you can ask right now. If you want me to discuss any question again, I will discuss it. Anyone, just raise your hand, or you can write in chat box. Any question or any doubt that you might have faced during watching lectures, yeah, during this discussion. Anyone? Vishnu, Sai Chandna, everything will be okay, sir. Thank you. Okay. Sai Chandna. So thank you for attending this session. So I hope I was able to explain everything to you, and I request you to join again next week at same time. Uh, okay, thank you. So I will be Tahija. Do you have any doubt? Yeah, any question? You can also ask, or else we can end the session. And I request you to please join next week also at same time. That is from 7 to 9 p.m. And I request you to please come up with the question. So this might be little bit boring also. Boring? No, I won't say boring, but you know what I mean. Communication should be both way, not a single way. What's the point? Like I will be just speaking for continuously for 2 hours. There are high chances that okay, just enough of this. So I am ending the as you don't have any question. I am ending the lecture session. Thank you. Good night.